Abdul Rahman. I'm a lecturer at a public university in Kenya. I deliver lectures in computing and informatics. In our last lesson, we talked about the type of variables, and we have seen that there are two types of variables in memory management. Basically, you had seen that they are what we call the global variable and what you call a local variable. So today we are actually going to extend onto the three principles of memory management. We had the type of variables, the memory layout, and finally the method of allocation. So today we are going to talk about the memory layout, and on that particular journey we are going to find out what is the definition and actually what is the memory layout itself, and finally we are going actually to implement. So let us start on that particular journey. So memory management, actually let's start and define what is actually memory. So into that particular one, we found out actually that a memory is a storage space. Actually memory, it is nothing but a storage space. But what does it store? It actually stores basically data and instructions. So it stores data and instructions meant for what? This data and instruction, they are needed by the CPU, that is the central processing unit, for its manipulation. So basically that is what actually it is memory. But however, physically a memory, it actually can be divided into two. It's what we call up RAM and what we call up the ROM. So RAM means random access memory, and ROM, it is read-only memory. So the RAM, actually when you're talking about the RAM actually stores temporarily, while ROM, read-only, as its name suggests, actually stores permanently. So actually this actually takes out into our next subtopic, the layout. So here we have got the memory layout. How is it actually laid out? So memory, actually it is laid out into 4 segments. So the first segment here, we are having what we call up the code segment. And then the second segment here, we have got the data segment. And then the third segment here, we have got, it is the heap. And the fourth segment here, we have got, it is the stack. So let's explain each one of them and see actually what does it do. So we have got the code segment. Actually this particular segment basically contains machine code. So this one contains machine code, and actually this particular machine code, actually it is what you call read only. Therefore it is used to actually prevent accidental manipulation of this particular data. And then we have the second one, which is called the data segment. And this data segment, actually it contains constants, initialized variable, and uninitialized variables, and also it contains both the local variables and the global variables. So we can see the importance of the data segment containing both the local variables and both uh, uh, the constant, initialize, and actually an initialize variables at the same time. So the third part. So let's go to the third part. So this was the second part. Let's go to the third part. So the third part actually contains the stack, and on the stack, basically we are saying actually the stack contains actually the local variables in a function or into a block or statement. Also, actually, when you're talking about the stack, it also contains the arguments which are passed into a function, and also it contains what you call a recursive function. So basically that particular segment of a memory will contain all those. And the fourth one, it is what you call a heap. So this particular heap, basically the heap segment, actually this is a free segment, and it has what you call very much flexible memory. It can both increase and decrease, and also can be free. So basically those are actually the four layout within a memory, and when you see the stack and the heap, mostly it is found on the RAM, whereby it has got the temporary type of memory. So that actually makes up us to go to the next part of it, whereby we want to demonstrate how we can implement the same into dev C++. So here we are going to declare up some function. So here we'll call it maybe a void product, and that it will take up, we pass on some two variables, int a and int b. So basically what we are trying to do here, and in this particular function we are going to declare some variables. So when we're declaring here, we are going to declare a variable, maybe called okay, we are going to declare a variable called mult or multiple. Multiply. So this particular variable, actually when we see this particular variable, according to our definition of the layout, it will be actually at the data segment, and then we want to actually access it. So the multiply should be equal to a plus b, I mean a multiplied by b, and then from here we are trying to print, so it will be printf and here we are saying actually the product of a and b should be equal to %d, and here we are having our multiply, we are having our multiply, and we are finishing up this particular function. So basically if we go back now, we want to call up our function. here we can initialize. Let's say int x equals to 20, y equals to 40. Here basically what we have done, we have actually, this will be actually on the data segment, because we are saying in our data segment all initialized, uninitialized and local variables actually will be in the data segment. And then here we are actually calling up our product. So here we are calling up our product. So we are calling up our function product, and we are passing on our x and y. So we have seen when we actually, this will be when passing up argument within a function, it's actually in the stack. So this will be on the stack segment. So that is our demonstration showing actually each and every statement, where does it belong on a memory layout. So let us run this particular program and see the outcome of it. So when we run this particular program, actually we are seeing up the product of A and B, it is actually 800. And that is actually the demonstration of this particular concept of memory management. That is actually we are talking about the memory layout. In our next session, actually we are going to talk about the memory allocation method. However, don't forget to subscribe onto our next session, and for now I say bye.